Hello, Algebra 1. This video lesson is about slope, the slope of a line. It's what slope is, it's how to calculate the slope of a line, and it's how to use the slope of a line in a problem. It comes straight from chapter 4.4, and it's probably one of the most important lessons of the year in Algebra 1. So let's get started. First of all, here's a basic example. We've been talking about points that we might have plotted before and drawing lines between them. Well, here are 2 points. I started with the point 3,4 and then I have the point 5,7. Slope is that change that happens as I move from 3,4 to 5,7. And in fact, I want you to think about slope often as change, or the rate of change, how quickly you change from one point to another point. The textbook explains it this way. It points out that you could have gotten from that first point to that second point, instead of going straight there, you could have gone laterally or side to side and then vertically or up and down. And this concept becomes really important in calculating slope. We use this formula. Slope is equal to rise over run. And rise means how much y changes. Run means how much the x amount changes. So let's look at these. I have a y value originally and then a y value the second time. So if I look at that difference, y2 minus y1, that's how much I rose. That's how much I went up. Similarly, for x, I have an original x value and then I have a next x value. If I look at x2 minus x1, or here, x2 minus x1, that's how much I went from side to side. That was my run amount. And so slope is this change divided by this change. The change in y, as it says here, divided by the change in x. Let's look at a specific example, going back to the one, in fact, that we just had. 3,4 is my first point, 5,7 is my second. Well, like it shows in red here, my y amounts are 7 and 4. 7 minus 4 is 3. That was my rise, 3 units or 3 steps. My run, 5 minus 3, or 2. I went side to side 2 spaces, 2 units, and up 3 units. So like it says here, slope is equal to 3 over 2. The rise, the change in y, which was 3, over the run, the change in x, which was 2. So I'll simply say that my slope was 3 halves. Or you could have said it as 1.5. That's fine also. Notice that you really only need 2 points to find the slope of a line, and that's a key point, a key concept that we'll come back to frequently. We may only ever find 2 points, and I'll ask you, what's the slope of the line that goes through them? Well, you don't need more than those 2 points. Notice this, please. There's a correct and an incorrect way of calculating slope. y2 minus y1 over x2 minus x1 is correct. It's also perfectly fine to do y1 minus y2 over x1 minus x2. And sometimes you'll find it's better to do it that way. As long as the order is the same, the order for y's is the same as the order for x's, you're fine. Incorrect, though, happens when you've got the y's done one way, y2 minus y1, but the x is done the backwards way, x1 minus x2. So make sure that you don't ever get the orders different. If you do, you're going to get an incorrect calculation for slope. Let's look at some examples here. Positive slope happens in a case like this one. Let's plug these values into our equation for slope. So like we've said before, y2 minus y1 is going to be my rise. Well, that's 4 minus 2, as they've written here, 4 minus 2. And 3 minus minus 2, as they've written here, is going to be my run. Okay, so 4 minus 2, that's 2. 3 minus minus 2 is the same as 3 plus 2, or in other words, 5. 2 over 5, that's my slope. Anytime you have a positive amount, it doesn't have to be a number bigger than 1. It doesn't have to be a whole number. It can be a fraction. As long as it's positive, that's a positive slope. And here's the picture of the slope of the line that goes through these 2 points, or actually the whole line that goes through these 2 points. And notice, if you've ever seen, for example, in reports about the stock market, if you've ever seen a report showing the stock market trend going this way, you know that's good news, or in other words, positive news. So I hope you'll remember it that way. This is a positive slope. Let's look at a negative slope just to compare it. Well, here are 2 points. Plug them into our equation here. Negative 3 minus 0 on the top, positive 3 minus 0 on the bottom, and what we end up with, negative 3 minus 0 after all is negative 3, and positive 3 minus 0 is positive 3. This simplifies down to negative 1. Well, that's a negative number, and any negative number for slope makes a negative slope, or a downhill slope. And I hope you'll think of it again, like with the stock market. If you saw this, you would know that was bad news or negative news for the stock market. And any picture that looks like this has a negative slope to it. 2 other scenarios. You could have a horizontal slope, and that's called a zero slope. Let's look at the specific example they've given us here. I'm going to have 2 minus 2 on the top, and I'm going to have 3 minus minus 1, or in other words 3 plus 1 on the bottom. Well, 2 minus 2 is 0. 3 minus minus 1, well, it doesn't matter what I have on the bottom. It turns out that it's 4, but 0 divided by anything is 0. And anytime you come up with 0 for your slope, you have a horizontal line. And here's that example. I'm going to talk about this a fair amount in class because it's a key point, a key concept that I want to make sure that you get. But for now, I just want to make sure you've noticed that whenever you have a flat line horizontally, it's called a zero slope. Anytime I say it's a zero slope, you should realize you're going to get a flat or horizontal line. Let's look at the opposite scenario, a vertical line. Here's an example with points. Let's plug them in. 1 minus 4, or they've decided to do, look at this, they've decided to do them out of order this time. That's okay. 4 minus 1 on the top, and 2 minus 2 on the bottom. Okay, well 4 minus 1 is 3, 2 minus 2 is 0. Well, wait a minute, I can't divide by 0. You should have learned that in middle school. Maybe you even learned that in elementary school. Anytime you do, you get a result that's called undefined. And in fact, that's what we would say about the slope of a vertical line. Its slope is undefined. Let's plot these points on a graph, 2, 4, and 2, 1, and you'll see they do end up on a vertical line. So again, I'm going to talk about this a fair amount in class, but please remember, anytime you see a vertical line, it means the slope's undefined, and anytime I tell you that the slope's undefined, it means the picture is going to be of a vertical line. Moving on here, I should be able to give you the coordinates at 2 points, and even without calculating the slope, you should be able, if you just plot them on a graph and draw a line through them, you should be able to tell me just by looking at the graph, is it positive, is it negative, is it zero slope, is it undefined slope? I'll do the first one. I'll plot 1, 5, and 4, 3. There they are. I'll draw the line through them, and clearly that's bad news for the stock market. That's a negative slope. Now I'd like you to hit the pause button and do 5 and 6, and I'll show you the results. Okay, I know that for me in the video only a few seconds went by, but I'm going to assume that you paused, went away for a few minutes, drew these graphs, and now you're back. The yellow one, the yellow line here is for 5, and notice it is those 2 points, 2, negative 4, and negative 3, 2, plotted here, and the line through them. That's a negative slope, that yellow line. The green one, which matches number 6, is a positive slope. That would be good news on the stock market. Obviously, even steeper would be better, I suppose, but that is a positive slope. Now, you also, if I give you the coordinates at 2 points, you should be able to calculate the slope without drawing the graph, just by plugging it into that rise over run formula that we have. So here's a reminder of that rise over run formula. Also a reminder, my first point is going to be x1, y1. My second point is going to be x2, y2. So I plug these values in place of these letters, like so, and I've got 10 minus 4 over 1 minus 0, in other words 6 over 1, or in other words 6. So my slope for this 7th question, the answer is slope equals 6. Now I'd like you to do 17 and 18. Hit the pause button. When you come back, I'll show you the answers for those. Okay, there are the answers for 17 and 18. I haven't worked these out, but I'd be happy to do that with you if you want to come in and ask questions. If you didn't get these same answers, if you didn't get undefined for 17, see if you can figure out why. And the same thing for 18. See if you can understand why you didn't get negative 5/2 if you have a different answer. I'm going to move on to a word problem. Let's see how we can use slope in this word problem. Very important what they say here, and I wish the textbook made a bigger point of talking about this. Slope is the same thing as the rate of change in any kind of story. So for example, back early in the year we talked about the idea that you keep coming back into your kitchen and more cheeseburgers have disappeared from the plate. Well, that change, that rate of change in what's happening to the number of cheeseburgers, you could call that the slope in your story. In this case, the story is about the height of a parachutist, and the height keeps changing. So the slope is going to be the rate of change in the height of that parachutist. So how would I figure out the slope in this story? Well, first of all, I know that I'm used to working with x and y, but I don't have a letter x or a letter y in this. So you hit the pause button and see if you can figure out which variable in the story is the independent variable and which variable in the story is the dependent variable. Okay, I'm going to assume that you hit the pause button and thought about that. The independent variable is time, and the dependent variable is height. Okay, so now let's see if I can plug time and height into my slope formula. Well, remember, here's my slope formula, so if y is the same thing in this story as height, then I'm looking for h2 minus h1, and if x is time, then I'm looking for t2 minus t1. Now I plug my numbers in place of those letters. There they are. And I do the arithmetic, and I find that 2115 minus 2500 is negative 385, and 35 minus 0, of course, is 35. Again, I do the arithmetic, and I find that what I have there is negative 11. Negative 11 what, though? My rate of change is negative 11 something. Oh, now I have to remind myself, that's right. These were in feet, and these were in seconds. So I've got negative 11 feet per second. My rate of change in this story is negative 11 feet per second. Based on that, I'd like you to look at these two problems, hit the pause button, read them through, and like it says, find the rate of change for the library book story and find the average rate of change for the voter story. When you come back, I'll show you the answers. Okay, I'm going to assume that you did that. The rate of change for the library books is a positive slope, 750 books per year, because it's increasing. The rate of change for the voters is a negative slope, negative 2 million per year, because it's decreasing. If you didn't get these answers, have any questions about this, don't hesitate to ask me when you come into class. I'm going to move on to this example here. You should be able to find the value of y that you would need in order to achieve the slope 2/3. So let's read through this. I'm given this point, negative 2, 1, and I know something about the second point. I know the x value is 4, but I don't know the y value. But I do know the slope. Well, let's plug this information into the formula that we have. I know this, the formula is this. I plug in place of m, I plug in 2/3, and I plug in the values that I'm able to here on the right. I know the 1, the 4, and the negative 2. I just don't know the y. All right, well, let's do our algebra. 4 minus 2 is 6. So I've got 2/3 is equal to y minus 1 over 6. I move the 6 over by multiplying both sides by 6. And on the left side, 6 times 2 is 12. 12 over 3 is 4. So I've got 4 on the left. These 6's cancel, so I've got y minus 1 equals 4. All right, I move the 1 over, and now I know that y equals 5. Okay, you should be able to do a similar problem. I'm going to show you how I've worked out 19. I'll uncover this in a second. What I'm going to ask you to do is number 21. So here's the fully worked out solution for 19. I have this information, I've plugged it all in, and I've figured out that y is 1 for question 19. Read through all of this, hit the pause button, make sure you understand what I've done here, and you should be able to do 21. And okay, there's the answer for 21. The answer is y equals 14. If you didn't get that, hit the pause button. Here's your homework.